Welcome and good afternoon to Falling Walls Lab Queensland 2020. This year we have taken a different approach by way of going alive and online to enable our best and brightest researchers from Queensland to present their topics and how is it breaking walls for the future. I'm Professor Hans Bachor from the Australian Academy of Science and have the pleasure to guide you through today's program. I'm joining you in Brisbane from chilly old Canberra. Firstly, please let me acknowledge the traditional owners on the land on which we stand and recognize their contribution connected to land, waters, and culture. I pay my respect to the elders, past and present, and elders from other communities who might be here today. It's exciting to be here as your MC for the second annual Falling Walls in Queensland and to see all these young research ready to share their incredible work. Now, this program is a partnership between Study Queensland, the Falling Walls Foundation, the Embassy of the Federal Republic of Germany, the German Consulate in Brisbane, and the Australian Academy of Science. What is Falling Walls? It's an initiative created in Berlin, Germany, the place where in 1990 the wall fell and many great ideas turned into action. Action for a peaceful world, for a safe and prosperous and healthy future. Falling Walls Labs brings together young scientists, engineers, and professionals from across the globe to present their vision, how to make the world an even better place for all of us. There's 1,000 ideas from across the globe, literally 1,000, and they have all nominated through about 70 parallel competitions around the world. The key event will be held in November in Berlin when 100 presenters will address an audience of decision makers, people who can turn ideas into actions. Each of them has just 3 minutes to make their case, to explain the wall that is in the way for progress, and to explain how this can be done. So, who will be the influencers of the future? We will send a team from Australia, selected in a national event at the Australian Academy of Science this year for the first time. This will be in September with a national jury, which will find the most impressive visions from our country. 10 young colleagues will compete for a place on this team, and amongst them will be 3 from Queensland, from today's program. Later on, we will show you the overall winner of Falling Walls Labs 2019, Rhys Peary. He started right here in Queensland. So let's have a look at Falling Walls.
Intense, that's how it was. 3 minutes was shorter than you think it is.
3 minutes, it's enough to say what's the purpose, what's the problem you want to solve, how you're going to do it, and what does it take.
What you're looking at right now is the first schematic for a cure for the deadliest infectious disease known to humanity.
I talk a lot, so at different presentations I see myself running beyond time. So the participation has helped me learn how to carve my story and then present it in a pitch form in a very short time.
Thank you very much. I really fell in love with this event because it brings together all the great minds on one stage.
You need to be also out of the box in order to share, to feed your own research with the contact with the others.
I hope that the future sees more collaborative efforts like this, where people come together, bring in different strengths, and fusing those together to solve complex problems. And science will be key to that journey.
Thank you for tuning in on Facebook Live today to support our 10 researchers who will be pitching to you today, to the online audience and to our online jury. All of them vying for one of the winning positions to qualify them for the finals in Canberra in September. Now here is a quick view of who our presenters today. We have Breaking Walls of Diminishing Actual Sand by Danish Kazmi, University of Queensland. Breaking the Wall of Prostate Cancer Treatment Resistance, Ahala Vinaranage from the Queensland University of Technology. Breaking the Wall of Language and Hearing Barriers, Chen Yen, University of Queensland. Breaking the Wall of Broken Wounds, Eamon McKenna, Queensland University of Technology. Breaking the Wall of Unwanted Bones, Selvan Samuel, University of Queensland. Breaking the Wall of Drought in Chickpea, Oluwaseun Akilada, University of Queensland. Breaking the Wall of Healthcare Inequity, Kyo Michelle Tran, Queensland University of Technology. Breaking the Wall of Genetic Complexity, Alan Robertson, University of Queensland. Breaking the Wall of Advanced Sugar Manufacturing Issues, Shalani Marasinghege, Queensland University of Technology. And finally, Breaking the Wall of Science in Writing Classroom, Jarl Leibovich, University of Queensland. Now, during the jury's deliberation, you, the audience, will have the opportunity to vote for your favorite presenter and topic for our People's Choice Award. Voting will occur via the Study Queensland Facebook page. Please get yourself familiar with this and please vote. You might want to Twitter. Our hashtag today is #FallingWalls. And you can tag @StudyQLD and @falling-walls. Now, to officially open the event and welcome you all, I would like now to invite Mr. Scott Ashton, Director of Study Queensland.
Thank you, Hans. Again, welcome to Falling Walls Queensland Lab 2020. My name's Scott Ashton and I'm a Director of Study Queensland. I'd like to add my acknowledgement to the traditional owners, to Houndsers, and pay my respect for elders. I recognise they hold the memories, traditions and the culture and hopes of Aboriginal and Torres Strait Islander peoples across the state. It's great to be here today and I'm looking forward to hearing from the presenters and learning about their exciting research projects. I would like to take the opportunity to thank Hans for zooming in today and hosting our event. This is our second year of hosting Falling Walls Lab Queensland, and we're thrilled to be building on the success of Queensland student Rhys Pirrie, being the first ever Australian to be named Young Innovator of the Year at the 2019 Falling Walls Building. Many of you will already know Study Queensland's role, but I thought I would touch on this for the general audience. Study Queensland is the Queensland Government's lead agency for supporting and developing the students and providers in the international education and training sector across Queensland. Study Queensland endeavours to create a strong and sustainable international education and training industry that facilitates global engagement, produces lifelong ambassadors for Queensland, and becomes a key catalyst for growing Queensland's knowledge economy. The Queensland Government's investment in science and research, particularly over the last 15 years, have laid a strong foundation from which we can address future challenges. We have established a global reputation for science excellence and research capability and achieved some outstanding results. For example, the development of the Hendra virus vaccine. Queensland invests billions of dollars into research projects, skills and facilities, creating a collaborative network of institutes and precincts across the state. We are the home to world-renowned universities that offer hundreds of courses to around 60,000 international students. And all of Queensland's universities conduct research into a wide range of discipline areas and participate in national and international projects through collaboration with government, industry and other research institutes. Through this commitment in developing world-leading research institutes, Queensland has been able to continuously demonstrate itself as a leader in game-changing innovations, such as a needle-free vaccine delivery device, a vaccine to prevent cervical cancer, the multifocal contact lens, and also the highly anticipated COVID-19 vaccine. Thank you. I hope you enjoy the event this afternoon. I'll now hand back to Hans.
Thank you for that welcome, Scott, and thank you to Trade and Investment Queensland and Study Queensland for supporting this initiative. Wow, ladies and gentlemen, we now proceed and start the presentations. Each presenter will have 3 minutes to pitch their report. This will be followed with 2 minutes of questions and comments from the jury to the presenter. And a reminder for you at home, keep track and do your own scoring so you can participate and vote in the People's Choice Awards via the Study Queensland's Facebook page. So, please welcome our first presenter, Danish Kazmi from the University of Queensland. He will be presenting on breaking the wall of diminishing natural sand.
Have you ever heard about the idea of turning a waste into a treasure? Well, my PhD research is all about that. And today, I'll be going to share with you how I am hitting 3 birds with 1 stone. We all are part of this planet, and the Earth provides us all the resources that are necessary for our well-being. But increasingly over time, the impact of human activities is causing a pressure on the environment and disturbing the ecological balance of our planet. One of the reasons for these undesirable effects is that humans are extracting more resources out of the earth than it can sustain. So I presume you all enjoy your beach holidays, but the next generation may not. 2/3 of Southern California beaches are expected to disappear in the next 80 years. Do you know why? This is due to the depletion of sand. Natural sand has now become the second most widely consumed natural resource on the planet after fresh water. It is estimated that nearly 50 billion tons of sand is consumed every year. Environmentally, excessive extraction of sand physically undermines the riverine and coastal ecosystems, increases suspended sediments, and causes erosion. Therefore, we need to find an alternative to sand that is sustainable and cost-effective. So what can be a win-win solution? The ever-increasing quantities of waste glass can be a potential alternative to sand, as both materials have a similar chemical composition. It is estimated that nearly 1 million tons of waste glass is stockpiled annually in Australia, and its disposal has become an environmental challenge due to its limited end uses and non-biodegradable nature. My PhD research aims to investigate the behavior of crushed waste glass as an alternative to sand for ground improvement during construction. I will experimentally analyze the performance of composite samples containing weak soil reinforced with a waste glass column. So the question arises why we should use waste glass as an alternative to sand. Well, the answer is environmental, economic and technical. From an environmental viewpoint, the use of waste glass can promote closed loop recycling and reduce the carbon footprint by nearly 60%. Secondly, natural sand is becoming increasingly expensive and its international trade price has increased to almost 6 times in the last 25 years. From a technical viewpoint, glass is theoretically 100% recyclable. And my initial research shows that the geotechnical parameters of crushed waste glass are similar to natural sand. Therefore, the sustainable utilization of waste glass and conservation of natural sand will not only provide economic, environmental and technical benefits, it will also help us to protect our planet and lovely beaches for our upcoming generations. Thank you.
Welcome one of the jury members, Dr. Jessica Gallagher, to ask the question to Danish.
So fantastic presentation. My question was really in terms of what stage your research was at. Is this still very much a concept, or have you been able to move into actual testing in terms of the stability and potential usability of recycled glass?
Well, firstly, my research started with the fundamental motivation of reducing our dependence on depleting natural resources and maximizing the recycling of waste. Natural sand has been diminishing globally, largely due to its enormous use in construction. On the other side, waste glass, the quantities of waste glass are increasing day by day, and its disposal has become an environmental challenge. Therefore, my research will potentially offer a double duty benefit by helping to conserve a precious natural resource and disposing of a non-biodegradable waste. Now, in reference to your question, well, currently my initial research findings are quite motivating, and in fact, some of my tests have shown that waste glass has outperformed natural sand in some technical testing. For example, waste glass has shown to have superior permeability and abrasion resistance as compared to natural sand. So based on the initial motivations, I expect that waste glass will offer at least a similar or ideally a superior behavior to natural sand in ground improvement columns.
Great, thank you so much.
Thank you, Danish and Jessica Gallagher. We're still experimenting with the time, so I think we'll leave it here at this point with one question. And, you know, if you make your answers fast, you get 2 questions. So I think we got the format now and you see the pattern, and we'll move on to the second presentation. So please welcome our second presenter, Achala Vidaranajib from Queensland University of Technology, who will be presenting on Breaking the Wall of Prostate Cancer Treatment Resistance. Over to you.
Good evening, everyone. Did you know cancer is so smart compared to us that it can tackle all our battle plans and win the war? Currently, 1 in 7 Australian men are diagnosed with a deadly cancer in one of the key organs in male reproductive system, the prostate, making it the most prevalent cancer in Australian men. This year, more than 3,000 men are estimated to die from prostate cancer. Globally, the number of diagnosed and death cases of prostate cancer are constantly rising. The prostate is a walnut-sized gland just below the bladder in males. And due to various risk factors, cells in prostate gland start to multiply abnormally and develop as a cancer. Until the cancer remains localized to the prostate, the patients are treatable with various treatments, such as radiotherapy, hormonal therapy, and surgeries. However, a significant proportion of them develop treatment resistance and progress to advanced metastatic cancer that can spread to other parts of the body, which will be impossible to be treated. Therefore, the question remains how cancer cells act so smart to evade from our all potential anti-cancer treatment. The most common mechanism it used to survive under treatment is alternative splicing, a mechanism that cancer cells use to produce structurally and functionally different protein from a single gene, what we call as protein isoform. When we design a drug to inhibit the activity of one protein isoform, there's a possibility that this drug will not inhibit the activity of alternative protein isoform produced by the same gene. I work on IRX4 gene, which is a cancer-promoting gene in prostate cancer. And significant levels of IRX4 protein have been detected in prostate cancer cells compared to normal cells. What we found is IRX4 gene can code different RNAs and produce different protein isoforms that has the potential to induce prostate cancer growth. Since these two protein isoforms are structurally different, we must design specific drugs which target these protein isoforms specifically to inhibit their activities in cancer. Previous evidence has shown that alternative splicing is such an important concept. For example, a novel protein isoform produced by the alternative splicing of androgen receptor gene has been found to be involved in developing treatment resistance in prostate cancer. And it has been already proven that this alternative protein can be targeted to inhibit prostate cancer growth. Similarly, we now aim to break the wall of prostate cancer treatment resistance by designing new drugs that can specifically target novel protein isoforms of IRX4 gene. This research is not just about finding a cure for treatment resistance, it's all about killing the seeds of cancer, so men don't need to live in fear anymore. Thank you.
Thank you, Hala, for presenting on breaking the wall of prostate cancer treatment resistance. We now have 2 minutes as I welcome our jury member, Mrs. Claire Blaine, to ask the question to Hala for comment.
Hi, that's really important research. Thank you for choosing that topic. And I just wondered, how is this technology different to other technologies that are currently being used to treat and others that are in the pipeline?
This mainly our studies focus on like one protein the target to prevent of the cancer progression. They mainly assume that this one gene and one protein concept, but we know that it has like great variety of proteome that we need to specifically target these protein isoforms also, because it can like induce like different treatment effectiveness in different patients and may cause different adverse effects. So that's why we need to like look at this isoform level function in cancer progression.
Thank you.
Thank you.
Thank you, Azala. And I now welcome one of our other jury members, Professor Michael Rosmann, to ask the second question.
Thanks, Hans. And Akala, you're a great presenter. Quick question. You talk about possibility and probabilities. What's the biggest risk that your research will not be successful?
According to my opinion, that protein isoforms are like more similar in characteristics and the structure in more similar. So when we target like specific isoforms like with different drugs, we need to first clearly classify what are the different features of these two isoforms separately, what are the electrostatic parameters and how they differ from its shape and their size, what are the domains they lack in some other isoforms. So I think it's like a very challengeable thing, but we can focus it, we can achieve that focus because like correctly characterizing all these isoforms. Similarly, we can like find some distinguished feature in one isoform, and then we can focus in that one to target this specific isoform to prevent the cancer growth specifically.
Thank you, Hala and Claire Blaine and Michael Rosman for the questions and answers. Now let's proceed to the third presenter, Sheng Yen from University of Queensland. He will present on breaking the wall of language and hearing barriers. Ooh, I think I made a mistake, a blunder here. So, show me the slide. Yeah.
In our daily lives, we encounter people from all walks of life. We interact one-to-one, in groups, face-to-face, and virtually. Especially in our current climate, we aim to stay informed for our health and be included in our communities. One of our most common senses, our hearing, is a gateway to how we interact. We hear to communicate and to connect. But what if we cannot hear and therefore are not able to listen to each other? What would you do? And I'm not talking about selective hearing here. We also use our words to interact. We use our words with purpose, to offer or to request information, to tell our stories and to empathize with others. But what if we cannot understand the meaning of the words? These barriers in hearing a language can especially be experienced by those who have hearing difficulties and who use a language other than English in this context in Australia. Around the world, 1 to 5 in 1,000 babies are born with hearing loss. In Australia, 1 in 5 households uses a language other than English. Our world is becoming more culturally and linguistically diverse, but our healthcare services are not necessarily adapted yet to this growing change. By not being able to understand what is communicated, there's the risk of delayed intervention. So what can we do about this? Together with my advisory team, we investigate how culturally and linguistically diverse families of young children with hearing loss access healthcare services. We look at each person's perspective, how young kids engage in play activities, how caregivers are informed and how much they feel supported, and how equipped clinicians and service managers feel they are in providing services to these families. What we found so far can be described in 2 key actions that are needed and have provided good outcomes: access and partnership. Access to a shared understanding of the care and the cultural backgrounds, and this could include involving interpreters, translate information, and visual aids, and partnership between families and professionals in making decisions together and jointly setting goals. Simple strategies could include asking for clarification, checking understanding, repetition, and also looking at nonverbal communication to look for clues in the level of understanding. Having said that, there's still so much more to unpack here. Through this research, families and professionals are given a voice. Through this research, we compile evidence to support best practice. The ultimate goal is that families and healthcare professionals have access to the best available information, resources, and strategies, and that they feel supported and included in making the appropriate health decisions for their children. Similar to our daily lives, we need to make sure that we have accessible communication and information, and that we build on each other's strengths, drawing from our diverse backgrounds, so that we can create a sense of belonging together, so that each of us can be present and be heard. Thank you.
Thank you, Jane, for presenting on breaking the walls of language and hearing barrier. Now, for the 2 minutes, I welcome our jury member, Professor Ren Yi, to ask the question to Zheng for his comments.
Thanks, Hans. Thank you, Zheng Yan, presenting the very important the topic. And 2% of Australians have hearing issues, and a lot of them have language barriers as well. My question is about your research significance from current practice. I assume you know Australian Hearing is based at Macquarie University, co-located with Australian government, Cochlear, the industry, and also with charities, and also with all the clinicians, and through the Macquarie Hospital. So what is the difference from your research from the current practice? Thank you.
Thank you for that question. Yeah, so as far as I'm aware of the current research with that, so for our project, we are looking very much at observations. So looking at natural clinical environments and trying to see from that what is happening, complemented by interviews to look at the perspectives. So I suppose our novelty in the research is looking at verbal and nonverbal patterns in communication practices in the appointment. And based on that, or at least how we do that, is to video record a session and use a method which is called conversation analysis, which is a very detailed analysis to look at, so again, the verbal and nonverbal patterns, and things like where the other language also is involved and where there might be hearing difficulties. So yeah, that basically is our novelty in that, yeah.
Thank you.
Thank you, Jen and Professor Renier, for the question and answers, which got us deeper into the topic. Now, please welcome our fourth presenter, Eamon McKenna from Queensland University of Technology, who will be presenting on breaking the wall of broken wounds.
Imagine you walk through the street and you get a pebble in your shoe. Now, for most of us, this might just mean a little bit of pain. For diabetics, this can be a death sentence. Diabetic foot ulcers are an unappreciated yet major complication of diabetes, and these ulcers can and do develop from things such as a pebble in your shoe. Up to 25% of diabetics will develop one of these ulcers at some point in their life, and for many of them, treatment will require amputation of the limb. But amputating the limb of someone who already has shown they can't heal properly is far from ideal, and unfortunately, 50 to 80% of these patients will die within 5 years. Now, what really transforms this pebble problem into a complete landslide is the fact that diabetes, the underlying cause, is the fastest growing chronic disease globally, and by 2045, there'll be more diabetics than the entire population of Europe. Now, couple this rising prevalence with the fact that these ulcers constitute a third of the cost of diabetes, yet receive a minuscule amount of funding. This is a global health epidemic that is hurtling towards us like a meteorite. But another field that's faced similar challenges and prevailed has been in cancer therapies. Breakthroughs in cancer therapies have been largely the result of shifting the focus from targeting the cancer cells themselves to the damaged immune system and weaker immune cells. These therapies, called cell and gene therapies, take the patient's own immune cells, modify them so they can specifically find and destroy the cancer cells again, and then re-inject them back into the patient. What they've been able to do is eliminate cancers. Now, a key component of these therapies is the fact they rely on sophisticated cells, which means that they can do things that no chemical alone can do. On top of that, we can alter these cells using gene modification, which means we can specifically tailor what these cells can do with what we want them to do. Now, the ideas behind these therapies are not necessarily new, but what the key breakthrough by our colleagues in cancer has been is they've demonstrated that they're now not only highly effective, but they're safe. So what does this mean for diabetic foot ulcers? Well, we know that these ulcers develop because the patient's cells have been damaged by diabetes and don't produce sufficient amounts of key wound healing molecules. Therefore, in my project, I'm using the same cell modification techniques used in these cancer therapies to target these damaged wound healing cells so that they produce these key wound healing factors. Diabetic foot ulcers have really been stuck between a rock and a hard place. But I strongly believe that cell and gene therapies will be the next wall to fall in healthcare, and in a sense, our SpaceX program against this hurtling, foot-shaped meteorite.
Thank you, Eamon, for presenting on the breaking wall of broken wounds. And for the 2 minutes of question and answers, may I ask again Professor Michael Roseman to ask the question to Eamon for comment.
Eamon, this is a great topic. You're a great presenter. And I like the idea of comparing what we do in one field, cancer, with another field, what we could do, diabetes. How much can you really achieve in what seems to be like an incredibly complex problem? So my question is, in the time you have as an individual researcher, how much can you achieve in this very complex problem?
Thanks. So thank you for your question. So what this is a very, very challenging wound model. And unfortunately, there's really not a lot of alternatives at this stage. In Australia, these ulcers result in 10,000 hospital admissions. and 5,000 amputations a year. And so whilst we're setting the bar high, what we want to do is be on the frontier of the refocusing of what cell and gene therapies can really be used for. And so cancer therapy has been the focus, and people are celebrating the successes that they've been able to achieve in that. But those successes do beg the question, if we can reprogram these cells that have been faced a similarly difficult and challenging task of beating cancer, can we not look at other diseases that have damaged cells and led to conditions such as these ulcers? And so that's what we're doing. So within this PhD, we're looking at, firstly, we've focused on the biomechanical aspect. And so we've developed a scaffold that's twice the strength of the skin. It breaks down into lactic acid so the body can get rid of it, and the cells can grow epithelial layers on it. And now we're focusing on the biological component. And so I think it's a big ask, but I think it's achievable. We'll be able to do some proof of concept for cell and gene therapies in diabetic foot ulcer repair.
Thank you, Eamon McKenna and Michael Roseman, for illuminating this topic deeper. And as you can see, 2 minutes for question and answer is quite a challenge. Now, please welcome our 5th presenter, Selvin Samuel from University of Queensland, who will be presenting on breaking the wall of unwanted bones.
Bones. Bones form the skeleton, shape our bodies, help us move, and keep us strong and sturdy. But sometimes bones grow within the muscles, fuse with the bones and joints, and can make the entire body rigid. Does it sound like a horror movie? Well, it actually happens in 1 out of 4 victims of traumatic brain or spinal cord injuries. This condition is called neurogenic heterotopic ossification. A few weeks after a trauma to the brain or the spinal cord, bones start growing within the muscles, fuse with the bones and joints in the vicinity, and can completely obstruct the bone, as you can see in the picture. Now imagine a person having to stand up, dress up, or eat with this kind of a hip. Heartbreaking. The only treatment at the moment seems to be surgical removal of these extra bones, which when the doctors have realized that they are there, but it's usually diagnosed quite too late. And even with surgery, just imagine how difficult it would be for the surgeons to chisel out these bones without damaging the actual bones and joints, the blood vessels, and the nerves in there. Very challenging task. Well, it would be great if we have a medication that stops these ossifications or these unwanted bones from growing. Easier said than done, because we still don't know why these extra bones occur. So, to understand this better, my lab has successfully reproduced this pathology in spinal cord injured mice and has discovered that the spinal cord injury must be accompanied by the muscle injury, where the injured muscles develop bones instead of muscles during the healing process. Strange, isn't it? Interestingly, clinicians have identified an increased prevalence of these bones in patients who have infections. And indeed, when we tried some of the infectious molecules from some germs, especially from some microbes, we were able to see an exacerbated bone growth in these spinal cord injured mice. Intriguing, isn't it? So, in my PhD, I will be trying all these molecules that can potentially cause worsening of this pathology and try relevant medications to stop these bones from growing. If this works, I will be able to help our very own soldiers, our favorite athletes, or our favorite anyone in the world, be it your own mother or your brother or your sister, have a much better quality of life by being able to sit up and have improved mobility. Thank you.
Thank you, Selvin, for presenting on breaking the wall of unwanted bones. So please let me ask our jury member, Professor Ian Atkinson, to ask the question to Selvin for comment.
Thank you. And Selwyn, thank you very much for a very clear and very engaging presentation. I'd like to know if the work on building the pharmacological model to date, where you've discovered that certain germlines or microbes actually exacerbate the bone growth, is your own work, and also have you managed to interest any commercial firms in the product at this stage? Because presumably there will be quite a lot of patients given the prevalence of spinal and bone injuries.
Thank you, Ian. That's a wonderful question. At the moment, we have some work going on related to commercialization of our products, but unfortunately, I'm not able to disclose the details because it's quite confidential at the moment, and it's going to be patented quite soon. So yes, we do have a lot of ideas in the pipeline, and we are hopefully there. And we've seen a lot of success with other projects that are going alongside this project. And yeah, we are having a good time with finding great things about this pathology, and we are soon going to be there. Thank you so much.
So could I ask Mrs. Claire Blaine to ask the second question to Selwyn, please?
Apologies, I lost my mouse for a moment. Wonderful presentation. Thank you so much. It's really exciting research that you're doing. I just wanted to, for my own personal reason, get a better understanding of how many people are affected by this. You said 1 in 4 victims of traumatic brain or spinal cord injuries. So what kind of figures across Australia would that be in terms of people?
It actually is the same number. Like, we have around 20 to 25% of people with spinal cord or traumatic brain injuries being affected by this problem. And not just these people, even people with severe burns and people with stroke also happen to manifest this problem. But burns is not neurogenic heterotopic ossification, though we have plans to work on it in the near future. I'm not working on it at the moment. So the prevalence is actually a bit more than what I spoke about. But yeah, it's something that needs to be addressed, and it's quite common, and it's something that's being unnoticed because we have a lot of researchers working on spinal cord injuries and regeneration of the spinal cord. But this is a secondary condition which actually gets sidelined. So we as a team are focusing on this, and we're getting good results. Thank you.
Thank you, Selwyn. Thank you, Ian Atkinson and Claire Blaine, for the questions and for the answers. We'll keep on practicing to stay within the 2 minutes, but I think we're doing fine. So, ladies and gentlemen, we are now halfway through our 10 presentations. I think they are marvelous ideas, great presentations, very convincing, not easy to judge. So keep on watching. Now let's welcome our 6th presenter, Oluwaseun Akilade from the University of Queensland, presenting on Breaking the Wall of Drought in Chickpea.
Chickpea is one of the most important grain legumes in the world. It has a high protein content, making it good for us, and fixes nitrogen, which is great for the planet. Chickpea is primarily grown in the semi-arid tropics, and Australia is the largest exporter of chickpea. Typically, chickpea is grown on residual soil moisture from the preceding season. Due to prolonged water deficits in the reproductive phase, terminal drought stress has a major impact on chickpea production, leading to a massive losses of up to 95%. For farmers, this is devastating. And with climate change, it is only expected to get worse. Thus, one of the most important goals for crop breeders is to improve drought adaptation mechanism in chickpea. Currently, it takes around 20 years to develop a new crop variety. But what if we could develop a tool that would drastically reduce the time required, and at the same time, develop high-yielding and drought-adapted chickpea variety that will help farmers increase their production without needing to increase their farmland area? Yes, we can break the wall of drought in chickpea. Here is where my research comes in. my research will develop a prediction model to fast-track the selection process during pre-breeding and breeding activities for chickpea varietal development and release. My research targets genomic information to predict the future performance of individuals based on their genomic data. Nowadays, an abundance of genomic data is possible at low cost. With some bioinformatics software, we can identify single nucleotide polymorphism in the genome. These are specific points in the genome where there are differences and see if differences are linked to drought adaptation in chickpea. By using a new technology called genomic selection, originally developed for cattle breeding, we will develop a prediction model for chickpea. We are currently in the process of developing this model from a training population that is a population that are ready in genotype and phenotype for their drought adaptation. Once we have done improving the accuracy of this prediction, we can use this model to predict and select individuals using available genomic information. Integrating the new tool in genomics-assisted breeding will ensure that farmers have access to high-yielding, drought-adapted variety in a shorter period of time. This will mean that chickpea will be better suited for farmers to grow around the world. The challenge is to break the wall of drought in chickpea, and we can do it. Thanks.
Thank you, Oliver Seung, for presenting on the breaking of the wall of drought in chickpeas. Now for the question, I would like to invite Professor Ian O'Hara to ask Oliver Seung and for him to comment.
Thanks, Oliver Seung. Great presentation and very important. I can see that there are going to be clear economic benefits for countries like Australia, but how would you describe and quantify the benefits for farmers in developing countries?
Thank you for that question. Like I said in the presentation that Australia is the highest exporter of chickpea. It's actually exported to places like India and some part of Pakistan and Africa. And because chickpea is a crop that is grown by poor resources farmer, and it's going to be impart them, because basically what we are going to do is to develop a kind of procedure and pipeline for both public and private breeding companies to follow suit so that they can be able to use it in their location, because drought is not something we can develop in Australia and that will be used across the world. But when we develop this procedure, it will help them to also implement it in their location. And in addition to that, this research is a collaborative work between Queensland, Coffee in Queensland and ICRISAT in India. So we are going to combine this. So at least the procedure will be at a go. Immediately we finish this development of the prediction, it will be useful in India, for instance, and Australia. So by implementing that already, then we can then give out a procedure and pipelines to other parts of the world, including the developing countries.
Thank you, Oliver Seung and Professor Ian O'Hara for your discussion. Now please welcome the seventh presenter, Kyo Michelle Tran from Queensland University of Technology, presenting to us about breaking the wall of healthcare inequity.
Imagine having your own island and having control of everything that happens on that island. For example, you could decide how tall everyone is, say by giving everyone the same height, or one taller than the other. How would you decide who's getting what and what's the best way to do it? That's exactly what we do in our research, but we work in the domain that may be more consequential than things like height. We work on things like who should get how much healthcare, and is that distribution fair? Why is that important, you may ask? Isn't healthcare supposed to be for everyone? Sadly, this is not the case everywhere. Take US, for example. In early March, when many Americans struggled to get tested for COVID-19, the NBA was able to quickly test entire basketball teams, including players who did not show any symptoms. How was the NBA able to access the tests, which at that time are luxury to everyday Americans? The answer, of course, is money. Inequity in healthcare has always been a long-running issue in many countries, with the rich being able to afford better healthcare, allowing them to stay healthy for longer, thus may not need to see the doctor as often as the poor. That being said, how much of the healthcare gap is driven by wealth? My study answers these questions by investigating the relationship between wealth and healthcare utilizations using a US survey that interviewed more than 20,000 homeowners over 19 years. Surprisingly, we found that more wealth actually reduced the likelihood of hospital admission, doctor visit, and the use of prescription drugs, while increased the use of dental services. It's even more startling learning that for the same person, 1% decrease in wealth could result in at least one more visit to the doctor. At the moment, 5.4 million Australian households would expect to lose, on average, 15% of their wealth due to the pandemic, which, based on my study, could translate to a surge of roughly 86.4 million doctor visits. Knowing this is what to come, what should we do? My study tells us that we should focus on reducing inequity in healthcare by not only providing equal access to healthcare, but also affordable services, especially to the disadvantaged group. That's it. Everyone should be able to get the healthcare that they need, not what they can pay for. Likewise, next time you are asked to distribute height in your island, instead of giving everyone the same height, maybe you should ask how much height they actually need.
Michelle Tran for presenting on breaking the wall of healthcare inequity. Now for our 2 minutes of question and answer, I would like to ask Dr. Jessica Gallagher to pose a question to Michelle.
Thanks, Michelle. Fantastic presentation and really timely looking at what we're seeing at the moment around COVID-19 and how that's playing out in different geographies. I just wondered, with regards to your research, how you wanted to translate or to apply that to support groups from low SES backgrounds. Are you already working with community organisations or government agencies around policy change? What's the plan?
So thank you for your question. So yes, I think the most important part of the research would be to be able to make a tangible difference to the community. So at the moment, we haven't got a chance to engage this research to many different organizations, which I hope through this competition would be a way for me to engage with the different party. Because I think personally, healthcare inequality is a complex issue, and we saw that there's a low socioeconomic group that are currently experiencing hardship from it, and it's going to be a long-term consequences. I'm currently also working on an additional project investigating some of the policy that US has implemented and some of Australia has been implemented, and to see if they're actually effective, especially for the low socioeconomic group. For example, I can mention the consumer-directed care and aged care market, or the relaxing of the nurse scope of practice, which I use US data, but at the moment in Australia, some of the states actually start allowing that and allow nurse practitioner to use telehealth to start consulting people. So I hope that study would potentially also involve and help with the access to care for the low socioeconomic group as well.
Thank you, Michelle and Dr. Jessica Gallagher for the discussions on health inequality. Now, please welcome our 8th presenter, Alan Robertson from University of Queensland, on breaking the wall of genetic complexity.
There are millions of genetic differences that make each one of us unique. And studying these differences is transforming the way that we think about healthcare. It can lead to better diagnoses, it can lead to treatments tailored to your unique physiology, and a better understanding of what's driving someone's disease at a molecular level. Now, when I started doing genomics, the idea of a personal genome sounded like complete science fiction that cost tens of millions of dollars to do, and only the ultra-wealthy could even think about them. Then something amazing, something almost impossible happened. The price to sequence a genome began to fall, and it kept on falling. And now we can sequence your genome for less than $1,000. From this, we've seen countries all over the world invest billions of dollars into the clinical rollout of this technology. But there's an issue. In doing this amazing, almost impossible thing, we left a lot of people behind. And looking at these people, they're the ones that are essential to adopting this technology. When we looked into it, we found that patients are wary, seeing their genome as a sort of Pandora's box. Doctors felt completely overwhelmed by the sheer amount of data in someone's genome, and the specialists whose job was to make sense of all this information were in such high demand, it could take years to see someone. It became clear to me that if we wanted to realize the potential of clinical genomics, we had to break down the walls of genetic complexity and make genomics accessible to more people. And to do that, and to make this happen, we leveraged support from the startup space. I learned about business, I got funding, and I formed a company. And together we began developing a platform to change things. Our platform takes genetic information from patients and visualizes it, and allows clinicians to see how a specific genetic variant can affect patient at the whole genome level, at the chromosome level, at the cytoband level, and at the level of individual genes. We then link this information to high quality data about the genes involved. It allows people to figure out what this all means. Essentially, we provide the same data and we support the same test, but we just present it in a way that's more accessible to everyone. Our first clinical pilot was completed earlier this year, and it's been very enthusiastically received. Now, making something accessible to the people that need it most shouldn't be a novel or an innovative idea, but from what we can tell, this is the first doctor and patient-centric approach of its kind, and it's already leading to new innovations and partnerships across the globe. Our first commercial application sees us working with groups in America to support doctors and families in the reproductive health space. These partnerships are designed to be economically viable and help our company grow to a state where we can support even more areas. Now, if we want to realize the potential of genetics and genomics, and we need to break down the walls of complexity, and we need to make the information accessible to the people that need it most. My name is Alan Robertson. I'm the founder of Clear Sky Genomics, and I'd like to thank you for listening to my talk.
Thank you, Alan, for presenting us about the breaking the wall of genetic complexity. Now, for our 2 minutes of Q&A, I would like to welcome our jury member, Mr. Alex Dreiling, to ask a question to Alan.
Thanks, Alan. Great presentation. And
sorry, I can't hear anyone.
Sorry, can you hear me? Congrats on the presentation, and congrats also on taking the plunge from academia into startup land. If you ever want to talk about this, let me know. I've done this myself a few years ago. So the topic that you're addressing is really, really
Alexander, I'm so sorry to interrupt you, but I've got some technical difficulties and I can't hear anything. I couldn't hear Hans earlier, and I can't hear you.
I can
would you mind if I exited and came back in, and we could answer this question later?
All right, I can exit and come back later.
Cool. I'll exit it and come back. Hans, it might be an idea to move the schedule along a little bit. I'm so sorry, everyone.
Yep. Thank you, Alan. There's just a technical problem. We'll find out how we compensate for that right at the end. So I think we might, while this is being solved in the background, thank you, Alex Dreiling, for trying to put the question, and we'll find an opportunity for you. So let's please welcome our 9th presenter, Shalali Marasinhegi from the Queensland University of Technology. And she will be telling us about breaking the wall of advanced sugar manufacturing issues. Over to you.
Do you know that Australia is the 3rd largest raw sugar exporter in the world? Out of total production, 95% is produced in Queensland, making sugarcane the main agricultural crop in Queensland. During raw sugar production from sugarcane, about 10 million tons of bagasse is produced as a byproduct every year. Out of this amount, a major proportion is used as a fuel for boilers to generate steam that's required for factory heating purposes. However, bagasse is a valuable biomass which could be used to produce bioproducts including renewable electricity. For Australian sugar industry to remain financially competitive, it has become a necessity to make better use of bagasse by improving cogeneration of electricity and other value-added products along with sugar production. For this to be achieved, bagasse consumption for factory purposes should be minimized, and this has been successfully achieved by improving the configurations of the evaporators such that vapor blend from juice evaporation is used as a heating source for successive evaporators as well as the other heating stages during processing. By this way, the cogeneration has been improved such that the surplus annual electricity production from Queensland sugar industry is equivalent to a total of 25% of Brisbane dwellings. However, this has created another wall. Higher temperatures and longer retention times of sugarcane juice in evaporators in high steam efficient configurations has caused higher level of juice degradation, causing increased sucrose losses during evaporation that accounts for a loss of 1 million Australian dollars per factory per year. An additional colour formation causes and affects the quality of raw sugar, and acidic products forming accumulates in the condensates, causing frequent corrosion issues and increased chemical oxygen demand. How to break this wall? Through comprehensive analysis of factory sugarcane juices in evaporation, we have found that reduction of impurity loading in the evaporator station could lower the extent of juice degradation. Additionally, laboratory work incorporating synthetic sugar solutions have proven that control of pH with increasing its buffering capacity of the juice could also lower sucrose losses and other impacts. By applying these mitigation strategies to the sugar industry, it will enable more income generation through cogeneration of electricity and other products while minimizing sucrose losses. Thank you.
Thank you, Chalani, for telling us about breaking the wall of advanced sugar manufacturing issues. Now for our 2 minutes Q&A, may I ask Professor Ian O'Hara to ask the question to Chalani.
Thanks, Chalani, and great work and a very important topic. So what is required for sugar mills to implement these solutions? And do you think this will directly result in an increased level of cogeneration from the sugar industry in Australia?
For the increased level of cogeneration, currently not all factories in Australia are steam efficient. So the factories with high level of steam efficiency is having significant sucrose losses. So once these sucrose losses are mitigated, it's this level of cogeneration can be applied to other factories as well, and that will improve steam efficiency of all Australian sugar factories and enable more sparing of bagasse for cogeneration. So that way it will increase cogeneration.
Thank you, Chalani. And Professor Ian O'Hara for the discussion. Now, let's welcome the final presenter for the Falling Walls Lab Queensland. And I'm presenting to you now Yael Leibovich from the University of Queensland, who is presenting to us about breaking the wall of silence in the writing classroom.
Raise your hands if you've ever been told to stop talking in class. Do you remember that feeling of frustration at having to cut short your conversation just to sit there silently listening to your teacher ramble on? Trust me, you are not alone. Now, what if I told you that talking is actually one of the most powerful ways to learn? That, according to the research, when students are given the opportunity to dialogue in class, their understanding and reasoning skills soar. And that's why in my classroom, students are rarely silenced. But for some reason, the value of talk has been forgotten when it comes to how we teach writing in high school. Don't blame teachers, though. Talk more to write better? It's seemingly counterintuitive, don't you think? The thing is, though, right now secondary school writing is in a state of national crisis and thus warrants our immediate attention. Domestically, writing is the one area of NAPLAN with a statistically significant decline. Globally, the data is equally concerning as many adolescents fail to meet the minimum literacy standards. Given that writing is a crucial skill in our daily lives, from text messages to ticket appeals, how we approach its instruction is in need of some serious reimagining, and I'm here to do just that. I have designed a pilot professional development program that is transforming teachers' attitudes and classroom practices. In contrast to the conventional teacher-dictated approach, my project is built around the key roles that student conversation and critical thinking play in writing. Here I bring to bear the game-changing power of collaborative reasoning on literacy learning. By collaborative reasoning, I mean the shared use of student talk to critically analyze and logically evaluate their claims and decisions when writing, a teaching method which no other model has meaningfully considered. For example, instead of telling students how to structure a writing task, break them into groups where they can rigorously discuss how they would approach it. Then, as a class, weigh the merits of their suggestions, a collaborative planning process that both supports and challenges student writers. Thus far, my findings show marked improvement, not only in students' written communication, but in their critical thinking, metacognition, and teamwork abilities as well, a highly transferable skill set for the 21st century. In addition, teachers, regardless of discipline, can now more easily identify and respond to the literacy needs of their classes due to the increase in student engagement. These findings are significant as they indicate that my approach is a viable one, and if applied more generally, has the potential to correct the downward trend in literacy learning while simultaneously preparing students to communicate more effectively in the real world. With these outcomes in mind, my hope is that more student talk today will allow young people to have a more literate and empowered tomorrow. Now raise your hands if you think that we should break the wall of silence in the writing classroom. Thank you.
Thank you, Yao, for presenting us about the breaking the wall of science in the writing classroom. May I ask our jury member, Mr. Ian Wine, to ask the question to Yao for comments.
Thank you, the excellent presentation. I'm wondering about the existing research activity on this topic and how you're extending the body of knowledge in this area. So essentially driving at the novel approach that you're laying out here.
Great, thanks for that question. So there's been a lot of research around the power of dialogue in the classroom in terms of helping to strengthen students' reasoning skills more broadly, as well as understanding of content. But not that much has been explored in the context of writing. In terms of pre-existing studies, they've more focused on particular areas around kind of grammatical understandings or syntax understanding, as opposed to taking a broader dialogical approach to just an understanding of what academic writing consists of and how to be a meaningful communicator. So in that respect, both in the context of professional development, as well as in the context of research studies, that kind of previous to my qualitative study hasn't really been explored, but I'm completely building upon some of the knowledge that already exists out there around the power of talk and how it logically fits with literacy learning. It's just about exploring further how we can achieve the marriage of the two.
Super, thank you.
Thank you, Yoel, and thank you for the question and answers. I understand we might be able to now have a question and answer session with Alan Robertson again. Technology might work now this time. So could I ask our jury member, Mr. Alex Dreiling, to have a discussion with Alan Robertson on the topic breaking the wall of genetic complexity.
Hey, Alan, can you hear me?
I can hear you. How are you, Alex?
Awesome, great. So yeah, I was going to say beforehand, so congrats on the presentation. Also congrats on taking the plunge from academia into startup land. I was saying before, like I've done this a few years ago. If you ever have a question, please let me know. So one thing that I was wondering, I mean, the topic that you're tackling is really complex and hard. So visualizing large quantities of data, but really once you've done it, it's comparatively easy to copy. So what have you done to date, or what are you going to do in the future to set yourself apart from existing or potentially future competitors?
Yeah, look, that's a great question. So with the existing competitors, what we've done is we've used agile and design thinking to test every assumption. And believe it or not, things designed for researchers aren't necessarily the clearest things for patients or their families. To protect that IP, it will be difficult to do. I'm not going to pretend otherwise, but we are actively exploring design patents in the US and our, I guess, active markets. You know, we're really hoping that first mover advantage will help us establish us and, you know, get us out into as many clinics as we can.
Yeah, great answer. Move first and move fast.
Thank you.
Thanks for that.
Well, thank you, Alan, for your patience and overcoming the little technological hurdles. And thank you, Alan Starling, for taking part in the Q&A. Great. So we have heard about 10 topics. And I think you all agree, these are great ideas. These are great opportunities. And now it's over to the jury to figure out which one should go on to the finale. Now, in a real life event, I think we would now have a huge round of applause from everybody. No idea how to simulate that online, but eventually we'll come up with an idea. So now we are splitting into several streams. The jury will now deliberate for 20 minutes. We'll be back soon to announce the winner and who will be representing Queensland at the national finale in Canberra. A reminder to all on you via the Study Queensland Facebook page. Please vote for your People's Choice Award. Please vote for your favorite presenter and go to the page and hit like. Stay tuned for some videos, including the last year's 2019 global winner, none other than Queenslander Reese Peary. We'll have a countdown clock on the screen to ensure you're back for the exciting announcement of the winner of Falling Walls Queensland 2020. Thank you.
Queensland has great strength across all the fields of science, but we're particularly strong in applying that in the real world. So the eco-sciences, agricultural sciences, health sciences are areas where we have clear strength.
The human population is rapidly expanding, and one of the grand challenges we have is how to feed the population.
We're helping people to produce more food that is healthier, and our unique combination of science and technology and a tropical and subtropical environment means that Queensland is the natural leader in this area of science globally.
We are making crops more resilient by making them more drought and disease tolerant. And globally, we are addressing the issues around nutritional security, which is how can we best enhance the nutrients in crops that are exported to regions where such deficiencies and health issues exist.
Aquaculture is the fastest growing animal production industry in the world and has a very important role in filling this requirement for animal protein into the future in more sustainable ways.
Here in the National Sea Simulator, we disentangle the different local pressures and global pressures, like land runoff and the effects on the Great Barrier Reef. We are collaborating quite widely with industries, scientists and government, because it's an issue that affects everybody.
Air quality is one of the top risks which humans face. Queensland provides a very good collaborative environment for working together with the international organizations, delivering research outcomes and then for utilization by our partners.
TRI is a unique facility globally because here we can do the basic science, we have the animal models to translate it, we have the manufacturing capacity to make products that are ready to go into patients, a clinical trials facility, and then straight into the hospital, all on one site.
If you want to treat a disease, you have to have someone take a tablet. That contains a compound. We make a difference by discovering those compounds from the wonderful resource and the biodiversity of Queensland.
Queensland is exciting. Not only are you at the doorstep of tropical disease in all its forms, you're also in a developed country with a tremendous health system and institutions and government who are really focused on the development of tropical health know-how that I think is gaining attraction worldwide.
Eliminate dengue is making a huge difference because dengue fever was such a burden. Many people sick. And now, because of the Eliminate Dengue program, we've gone from lots of outbreaks every wet season to virtually nothing.
The success has now meant that we can transfer this research overseas into international communities where we can have an even bigger impact on the transmission of dengue.
We're lucky that Queensland and Brisbane in particular is really a hub for mining technology and science. People around the world look to us for the new solutions that are going to drive innovation and change throughout our industry.
Small creatures, flying insects, can navigate with a very small brain and limited resources. So the challenge is, how can we do what a bee does in a plane?
Boeing has been partnering with Professor Srinivasan's laboratory on a research project aimed at taking what we can learn from birds and bees and make robots smarter, and that's world-class research.
Partnering with industries like Boeing, it gives us a feeling of our research being actually relevant to society, and that's a very big thrill.
I'm proud of the fact that I have been contributing significantly to leading a world top 50 university in this wonderful state that in turn put Queensland science technology on the world map.
Queensland science makes a difference not only in Queensland but also globally. We focus on science that is important not only for ourselves but for our region and the planet.
Queensland science.
Making a difference.
Queensland science.
Making a significant difference.
Queensland science is
making a difference.
Understanding our universe is a joint human pursuit. Our global future depends on educating and inspiring a new generation of scientists, engineers, and citizens.
Students across the globe now have access to an incredible wealth of knowledge and information about science and technology. That information, gathered over the last few decades, has revolutionised our understanding about the universe and our place in it, and has allowed us to develop techniques that have allowed us to explore the vast depths of our solar system and visit other planets.
USQ's astrophysics researchers are helping search for and characterise new exoplanets. We're using maths, science, and a little bit of imagination to help develop our understanding of what it takes for a planet to be habitable.
And here at USQ, we're taking an ever greater role in this exciting exploration. We're building a brand new facility that will play a world-leading role in the search for these new planets around other stars, and will help us to learn a great deal more about them.
USQ's Mount Kent Observatory is playing a leading role in this search. We're part of an international collaboration helping to provide NASA with full sky coverage in the search for and categorization of planets. We're also supporting space missions that will be launched in the near future. As a leader in observing the Southern Hemisphere skies, USQ is constructing Minerva Australis, a multi-telescope facility at Mount Kent. This will enable us to scour the Southern Hemisphere for new worlds among the stars. As USQ students, We're involved in observing new and exciting realms of stellar astronomy and the history of our solar system. It's a pretty exciting way to apply maths and science.
Well, really the Dare to Dream research project is all about trying to understand what the touring and residency program is leaving in the community. So we want to try and understand the impact on those young people in schools and in the community, and what that means for them across a longer term. Through Dare to Dream, we're trying to solve the whole idea that young Indigenous people in remote communities don't have access to creative artists. They have a lot of access to football and sporting heroes, but they don't have access to creative shows that are actually about them, for them, and by them.
Being able to depend and rely upon a partner or stakeholder like CQU, and to have those ongoing regular conversations about how do we continue to improve this, what else can we do, what can we do together. It's a really rich relationship. If we keep moving forward with our partners and stakeholders, CQU being a massive, enormous, integral part to that, to help us be able to look at what a tourable package to other communities outside of Queensland looks like, that's incredibly exciting.
Reaching out and to young people out there is certainly needed. It's really needed, and I think theatre is a very great way of reaching out. And it's really great to see a university that I work with being involved at this community level and highlighting a story particularly of me as Bukal in my journey from being born on a reserve and going to the heights of the UN. I think that inclusiveness, which CQU is all about, and including Indigenous people particularly, but as well as the community, it's really helped to lift the profile of who we are as a university working in North Queensland. My story, particularly Bukal, highlights and inspire young people to want to do something with their life and do something similar, then that's great.
So that story is an inspirational story. And what we want to do is provide opportunities for Indigenous artists to get out into those communities and to work with those young people in that community so that they're inspired about the potential for their own future. We want to know what impact in the long term that's going to have on them. So we want them, those young people, to be able to express themselves positively. And we want the community and their peers to hear from them about what they think a successful future would look like.
We're really wanting to capture much more of the student voice and hearing from them what it's meant for them, what they've learnt and where they want to go, where they think some of this, these ways of working might take them. And so it's building that capacity with Indigenous young people and artists in how to tell their stories, create performing arts work, building that audience though as well. And so this project will be helping to generate the next generation of young Indigenous arts workers, and particularly in far north Queensland. And I think that's a really exciting thing to be part of. It'll be longer term looking at tracking some of these kids. Where do they go? That some of them might go on to have careers in the arts, performing arts, but also, you know, that they have been able to dare to dream, but also realise their dreams.
Historically, we've had these drugs and therapies that are tailored to huge groups of people. It's not really catered to each person.
ADAPT stands for the Advanced Design and Prototype Technologies Institute. There's two parts to ADAPT. One is the advanced design component, the other is the manufacturing component. It is really open to what we think we can do. And it's not just medical devices. Our teams are now working on R&D for automotive, for mining, for environment, for fashion and entertainment, and for aerospace industries. So the advanced design component creates a personalised digital twin of the individual and the device. The digital twin then allows us to design a personalised biomedical implant or wearable device, which can then be manufactured using either 3D printing or other advanced manufacturing methods. ADAPT is about growing the full potential of personalised biomedical devices.
Halfway through medical school, I had a car accident and it caused a spinal cord injury. I became paralysed from the chest down, but also my fingers are affected as well.
Dinesh is a spinal cord injured patient and also a researcher and a doctor.
I finished medical school. I'm working as a doctor at the moment, but also a lecturer and an adjunct research fellow at Griffith. My dirty little secret is that I want to cure myself one day.
So what Dinesh and Claudio are doing is they're creating a personalised digital twin of Dinesh.
Digital twins is a representation of a person in a computer, okay? That means the digital twin will have your bones, your muscles, your joints, and so on.
Now, they're using that digital twin model to control how to stimulate Dinesh's muscles in rehabilitation.
We are saying we want to achieve a desired movement. How do I stimulate muscles in the optimal way to achieve that movement? And personalization in this context is essential.
Personalised treatment allows us to deliver precision medicine.
Sky's the limit. It's where the future's going to be.
Being able to move a finger or grasp something when you can't use your fingers previously, it changes things entirely. And with these type of therapies, that's how I hope that we can change the lives of people. And I'm confident that we'll get there.
We're using consumer-grade drones as an inexpensive approach for studying humpback populations on the east coast of Australia.
Drones for whales are great because they allow us to, one, get close to whales, which has been always challenging.
Once the drone's launched, it heads out over towards where the whale is, and you try to find it in the screen and then position yourself to be able to take your photos.
The main objective of this project was getting images so we could measure the whales.
I co-supervise honours student Emily Gregory in the research that's looking at using drones to measure whale length, for example.
Our measurements allow us some insight into the health and the body condition of the humpback. Their health and body condition is really important for their reproduction and population dynamics and their general overall health.
So that whale was
9.7 metres, that guy was. It's been brilliant working with a tourism platform like Sunreef.
We've been working with the University of the Sunshine Coast since 2014, and it's great even seeing data that they collected back then to now, and that progressing is just fantastic. So the bigger database we can help provide them with to build on is great.
Being able to go out with Sunreef gives us an opportunity to use the drones from a vessel, which we otherwise wouldn't be able to do.
We're actually all linked, so it's really important that we gain knowledge on the health of these humpbacks and the role that they play in our ecosystems in order to protect and conserve them.
Hello, and welcome back to our audience, to the presenters and the jury. Before we are going to announce the winners, let's quickly recap our 10 presenters and their topics. We have on the first one, Breaking the Wall of Diminishing Natural Sand by Danish Kazmi, University of Queensland. We have Breaking the Wall of Prostate Cancer Treatment Resistance by Ahala Vitahanage, Queensland University of Technology. Breaking the Wall of Language and Hearing Barriers, Zheng Yan, University of Queensland. Breaking the Wall of Broken Wounds, Ian McKenna, Queensland University of Technology. Breaking the Wall of Unwanted Bones, Selvan Samuel, University of Queensland. Breaking the Wall of Drought and Chickpea, Oluwaseun Akinlade, my apologies, the University of Queensland. Breaking the Wall of Healthcare Inequity, Kyo Michelle Tran, Queensland University of Technology. Breaking the Wall of Genetic Complexity, Alan Robertson, University of Queensland. Breaking the Wall of Advanced Sugar Manufacturing Issues, Shalani Mara Singhege, Queensland University of Technology. And then finally, Breaking the Wall of Silence in Writing Classroom, Yael Leibovich, University of Queensland. Please let me thank our jury panel. They have done it within 20 minutes, amazing. They had a tough task of choosing the winners for today, and they were Chairman of the jury, Professor Michael Rosemann, Honorary Consul of the Federal Republic of Germany, Queensland University of Technology. Professor Wen Yi, Pro Vice Chancellor International, University of Southern Queensland. Dr. Jessica Gallagher, Pro Vice Chancellor of Global Engagement and Entrepreneurship, University of Queensland. Ms. Claire Blaine, Chief Executive Officer, Life Science Queensland. Professor Ian O'Hara, Biofutures Industry Envoy, Queensland Government, and also Queensland University of Technology. Mr. Ian Wine, Global Head of SAP Institute for Digital Government. Mr. Alex Dreiling, CEO and co-founder of ClipChamp. And Mr. Ian Atkinson, Director of e-research, James Cook University. Well, I've been informed that the jury today, we have a winner. We will be awarding 3 winners for a spot at the national finale in Canberra. Now, please welcome our jury chair, Professor Michael Rosemann, to join me to announce the winners.
Well, thank you so much, Hans, and from all of us participants and jury, thank you so much what you have done over the last 1.5 hours of our lives. You have been incredible, well-spoken MC again, and we are deeply grateful. To all 10 presenters, from all of us jury members, you all are winners. You did an excellent job. You demonstrated courage, confidence, and competence, eloquence in your presentation, and efficiency for staying in a very challenging 10-minute time frame. So congratulations from all of us to all of you. Unfortunately, only 3 will be able to travel to Canberra, and in reverse order, it gives me now great pleasure to announce the 3rd highest ranked, but in any case, a ticket, at least a virtual one, to take part in the national contest. And this is Mr. Alan Robertson from the University of Queensland, who spoke about the falling walls in the domain of genetic complexity. Alan, from all of us, congratulations.
Thank you very much. I really appreciate it. I'd like to thank my team as well as UQ Ventures, and all the other groups that have supported me, like LSQ Catalyst and Bridge Tech. Thank you very much.
Well done, Alan. Thanks for your kind words, and good luck in Canberra, and then if it works out, hopefully also in Berlin. The runner-up, the second highest out of the 10 presentations we've seen today, was dealing with a very different domain, and it's the domain of silence in the writing classroom. So the winner is Yale Leibowitz from the University of Queensland. Yale, congratulations from all of us, from the entire jury. You've done an excellent job. Well done.
Thank you. And yeah, I'd like to thank my supervisors and just the awesome teachers and students I get to work with to make this happen. So thank you, very exciting.
An absolute pleasure. Well done. And it feels a bit like the Oscars. And if I could, I would open an envelope or have a drum roll. It is like the Oscars. Well done, whoever did this. Thank you so much. Well done. So the entire jury was enthusiastic about one proposal, and that demonstrates the strengths, the capability, the credibility, the confidence in our vote. So I like to now announce the winner of today's Falling Walls Lab here in Brisbane, and the winner is Mr. Eamon McKenna, who talked about broken wounds and the amazing idea of borrowing from cancer research to help many diabetic patients. Eamon works for the Queensland University of Technology. Again, from each and everyone from the jury, Eamon, you've done a great job. Congratulations.
Well, thank you so much for that. I'm really surprised. I thought everyone did such a great job today. I want to thank Hans for emceeing today. I want to thank the whole panel for their time in grading us. And I'd also like to thank my supervisors, Mike, Kat, and Travis, for their support and guidance in doing something that we believe is quite challenging. Thank you.
Thank you, Eamon. That concludes the part from my side. I like to thank all my jury panel colleagues. I'd like to, again, congratulate everyone, but in particular, I'd like to thank everybody who made this possible. Megan and the entire team. And again, Hans, congratulations and thank you so much from the bottom of my heart for what you've done here to become a boundary spanner between science and impact, between Australia and Germany. Thank you so much. And Hans, over to you again.
Thank you, Michael. And we have a fourth winner. We have a People's Choice. And the People's Choice is Akala Vidahavante on breaking the wall of prostate cancer. Congratulations, Akala, to the People's Choice vote.
Thank you very much. I would like to thank my supervisors, my primary supervisor, Josna Batra, and my co-supervisors and all the members of my group. I would like to say my gratitude, thank for them and all the Falling Walls team for giving me this valuable opportunity. Thank you very much.
Thank you. Now, before we close, I would like to introduce and welcome Richard Watson, Assistant CEO of Trade and Investment Queensland, to tell us a few words for the closing.
Terrific, Hans, and thank you very much for the introduction. Maybe I didn't get the drum roll that Michael had for the presentation, but certainly congratulations, Eamon, on that award today. Look, I'm here today just to really pass on the thanks to everyone for participating today. Firstly, can I congratulate everyone for the planning and the preparation and delivery for today. For those in the precinct last year down the valley, it may have been a bit unusual. Have we signed off last year by saying we look forward to joining you on Zoom via Facebook with pre-recorded presentations this year? That may have been a little bit of an exceptional one last year, but certainly I recall the presenters last year as they anxiously paced the hallways around the precinct as they prepared for the presentations. And certainly I do want to congratulate the presenters. They were an amazing array of talent this year with such a diverse and interesting range of research projects. I had the opportunity to look at them online. I also followed everyone on Facebook today and reviewed the presentations. And certainly you were tackling a lot of the wicked questions around prostate cancer, genomics, sugar and chickpeas, and Dinesh, no Queenslander wants to lose their beaches either, I'm sure. So certainly my hope for all the projects down the track is that that they progress to trade and investment clients that achieve both domestic and international success. So we certainly wish you all the very best there. But can I wish our finalists the best now as they now progress to the National Falling Walls Lab final in September. Hopefully you'll all be able to replicate Rhys Perry's success, and he obviously went on to win in Germany there too. So no pressure to those people that have progressed as well. An event like this, though, is not possible without the support from our partners and stakeholders. Firstly, can I thank Michael and the jury members for providing their expertise and advice today. It's certainly a tough job, and certainly with the 10 presentations today, that certainly was a tough job. And I know you extended the time by a few minutes, no doubt, to go through those very difficult deliberations. So again, a big thank you to the jury members. Would also like to thank our other stakeholders, the Falling Walls Foundation, for continuing to support Queensland in delivering a regional lab, to the Embassy of the Federal Republic of Germany and the German Consulate in Brisbane for their enthusiasm, participation, the Australian Academy of Science, and finally, Hans, a big thank you to you today for being our MC for the second year in a row and helping prep the judges and the presenters. Certainly also tackling some of those wicked IT challenges that obviously fall to events like this in our as we move online as well. So well done again to the winners. Good luck to all the presenters for their future research. Your contributions in these respective fields are certainly invaluable. And I think we should probably thank all the people that have been online today, the audience that have been with us, and I've been watching the commentary on the live stream as well as they've been cheering on their friends and colleagues along the way. So a big thank you to everyone for your participation today. Thanks very much, Hans.
Thank you, Richard. Thank you for your kind words, and you're indeed right. There's a great team behind it, and I would like to thank Daniel and his team, Megan, Ingrid. I mean, the people you don't see do at least as much work as the ones who face up to the camera. Now, what a great set of ideas. I think most of them will probably become reality down the track, and 3 of them will now go on to the finale. So I think the future looks bright. There's many ideas we'll have in Australia, and we keep you informed who will be Team Australia presenting in Berlin. So I'm looking forward to meeting 3 of you online again in Canberra in September. And I'd like to thank the audience. Thanks for making the time. Thanks for listening in, for all your comments, and keep on watching in September at the finale. Thank you. Bye-bye.
I was super excited when I read the announcement. Rhys is an absolute Queensland little rock star that's going and leaping beyond the shores of Queensland out into the global stage. It's super important to be able to showcase talent like Rhys, that clearly is an exemplar for the types of innovators and creators and entrepreneurs and scientists that we have here in Queensland. So I just want to congratulate Rhys. Congratulations, Rhys. Awesome.
We've developed a process where we take the non-recyclable fraction of glass, which is the small pieces that can't be sorted back into the right colour, and we dissolve that in a chemical which most people know as drain cleaner, and we make another chemical which is called sodium silicate, and with that we can make things like tyres, detergents, silica gel and even toothpaste. We've had a lot of interest from the waste management industry because obviously this is a big issue for them and a pain point. We've also piqued the interest of a few chemical manufacturers, and that's important because what we're trying to do is connect those supply chains, and so that's a really important part of the commercialisation process that's come about because of Falling Walls.
When I was in Berlin, I learned about the Falling Walls conference, which is an exciting, inspiring conference, and so I reached out to Study Queensland if they would be interested, and right away I think I found great support. I think you have to understand who comes together at the Falling Walls. There are Nobel Prize winners. There are the major players like Google, like Amazon, like Bayer, the healthcare sector. They're all coming together and they're seeing those young guys presenting their ideas. And if you are the winner of it, you know, you're up there. This will open doors worldwide for Rees with his research, what he delivered, and then I think his career will always be based on this win in Berlin.
Obviously the ultimate is commercialising the process and getting it through into a large-scale disruption of the sodium silicate and glass recycling supply chains. I feel really fortunate to have done my PhD in Queensland. It's easy to access top-quality researchers across a number of areas. So for me, I started in agriculture, went across to engineering, and I've ended up somewhere in the middle.
We are now working on the how we enable innovation across the state, not necessarily the why or the when, because we know that those mechanisms of time are ticking in a metronome pace that's gaining momentum. Once you get here, understand the real depth in terms of our culture around innovation, in that roll up your sleeves and work hard. Embrace the fact that we have a diverse state and that we're challenged by a tyranny of distance. You know, the amount and the vastness of our lands that exist in Queensland with the diversity of our natural resources is really actually the building blocks for innovation. And there's something spectacular in being able to leverage that for yourself in your own learning journey, but also for the goodness of maybe what you want to see and how you want to show up in the world.
I think Queensland's an environment where talent breeds talent.
Queensland is a place where you can start here and go anywhere.